Okay student, now in the last class we did chemical reaction and we have done two chemical reactions, so we'll continue with the third one. The third one, chemical reaction, still this one is also chemical reaction. Okay, now this one is, it's called benzoylation. Now why it is called benzoylation? Basically here the reagent is benzoyl chloride. So benzoyl chloride is C6H5COCl, or also you can draw it like this. Okay, or you can also draw it in this way, because you know that C double bond O part we can expand it, so C double bond O Cl, all are same. Okay, so basically it's similar to acyl chloride. So if you remember last reaction that we did, if it was acid chloride, yes or no? If it was acid chloride, that is RCOCl, so what answer, like what part we used to get, that I will add to amine by removing one hydrogen. It was C double bond OR, right? So if I apply the same logic here, C6H5COCl, so that part will be C double bond then C6H5, or also we can write it like this, C double bond O benzene ring. Yes or no? Now here same concept. Okay, same thing. So let's say it's reacting with question is CH3, CH2 and NH2. okay, and this one is reacting with this benzoyl chloride, right? And then any base can be given here. It can be NaOH, it can be KOH, it can be anything. Okay, and even if they don't give also, it's okay, no problem. So here what you will do, you will remove one hydrogen from this nitrogen, so, and then C double bond O and then benzene ring. Okay, that's the answer. Let's do another question. Suppose I'm giving CH3, CH2, 2 times NH, and then C double bond O Cl. Let's say it's reacting with this one, so you remove this hydrogen and you give this C double bond O and then benzene ring. Okay, now here one important point about this benzoylation is, there is one thing called Scott and Bowman reaction. SCH-double-T and Bowman, BAUMANN reaction. Now, so what is Scott and Bowman reaction? Is actually benzoylation, like same thing, like RNH2, it will react with benzoyl chloride, this benzene ring, and then C double bond O Cl, right? But the base here specifically will be NaOH. So if the base is NaOH in benzoylation reaction, so that particular reaction has specific name, is called Scott and Bowman reaction. So it will be NH and then C double bond O and then benzene ring. Okay, so that is Scott and Bowman reaction. So if I give an example, CH3, CH2, CH, CH3, NH2, and let's say it's reacting with this benzoyl chloride, and then it's reacting with NaOH and CH3, CH3, then here one hydrogen is removed, and then you have this C double bond O and then this one. So this is actually Scott and Bowman reaction. It's similar to benzoylation reaction or acid chloride reaction. The only thing that you have to remember is, if the base is NaOH, then it is called Scott and Bowman reaction. Now next reaction is the fourth one, it's called carbylamine test. It's also called isocyanide test. First of all, let me explain what is isocyanide. Isocyanide is also called isonitrile. Now basically, if RNC means nitrogen is the bonding site and NC is connected to an alkyl, then it is called isocyanide or isonitrile. If I give some example, CH3 CH2 NC or CH3 CH2 CH2 then NC, means nitrogen should be the binding site. Okay, now here what are the reagents used? Reagent will be chloroform, that is CHCl3, and then alcoholic KOH will be given. Sometimes they just mention KOH also, no problem with that. Now here what will happen, one NH2 will be there, and this one it will react with this reagent CHCl3, and let's say just KOH is given, and sometimes they might use alcoholic KOH also, and then it will be RNC. Okay, now this RNC, this isocyanide, it has very foul smell, bad smell. Okay, clear? Now remember, in this test is given by the isocyanide test, it is given by only primary amines. Okay, and secondary and tertiary amine does not give this test. So only primary amine. Okay, okay, let's do some question related to this one. So suppose I am giving you CH3 CH2 NH2, okay, and let's say it's reacting with CHCl3 and KOH. Okay, so this NH2 part, remove it, and in this part you write NC. Okay, now suppose another question, CH3 CH and CH3, so NH2 then CHCl3, let's say I can give ethanol and KOH also. Ethanol KOH is what? It's alcoholic KOH only, right? You know this, right? Before also I have explained this. So now this is the bonding side or not, and in this bonding side you have to add NC. Okay, so done. Next test is called nitrous test, and this test is actually used, like the remaining two chemical reaction that we will be doing is called distinction test. Okay, distinction test of 1 degree, 2 degree, 3 degree amines. So under this we'll be doing two chemical reaction. The first one is called, the fifth reaction in fact, it's called nitrous test. So what is the reagent here? Reagent can be either NaNO2 plus HCl. Okay, so this is the one, and this two, when it undergoes reaction, it gives you HNO2. So either HNO2 will be given, or the mixture of NaNO2 and HCl will be given. Okay, any one of the reagent they can give. Okay, now what will happen? So here let's focus on 1 degree amine, that is primary amine. So under 1 degree amine we can divide this into two parts. Okay, so first one is aliphatic amine. Aliphatic 1 degree amine means I am talking about this RNH2, means that NH2 is not directly connected to benzene ring. Now if this happens, so let's say RNH2 is reacting with, I can write any one of the reagent. Okay, either this one or this one. So let me write this NaNO2 HCl. If you write HNO2 also is correct, so it will produce RN2Cl. Okay, and this one is highly unstable. Okay, so immediately what will happen, in the presence of water, it will change to alcohol, okay. And this one is important, it will produce N2 and then it will produce HCl. This N2 gas is important, they have asked question on that, so we'll do that, okay. So always remember the final product for primary amine, like aliphatic primary amine, when it undergoes nitrous stage is alcohol, okay. Clear or not? And here one extra note point is that N2 gas is evolved and is used in the estimation of protein or amino acid. Remember that, okay. They can ask question on this, okay. But here the final product is only, so we can just write that 1 degree amine, 1 degree aliphatic amine will give final product alcohol, okay. Now if it is aromatic 1 degree amine, so 1 degree aromatic amine is NH2 and that NH2 is directly connected to benzene ring, okay. So now here what will happen, let's say this aromatic amine is reacting with NaNO2 and HCl, okay. So it will give you N2Cl. Now this reaction we did in haloalkane halurane chapter also, okay. So this one is called what? Benzene diazonium salt, yes or no? So this is one note point, the same structure N2Cl and benzene ring, it can be written in this form also, N triple bond N Cl minus plus this one, okay. Same, both are same, okay. So when it's 1 degree aromatic amine, it gives you benzene diazonium salt and this compound is stable, okay. To some extent it is not that highly stable compound, but to some extent it is stable, okay. So from 1 degree alcohol, aliphatic alcohol, we are getting alcohol, sorry, from 1 degree aliphatic amine we are getting alcohol, and from 1 degree aromatic amine we are getting benzene diazonium salt, which is somehow for some time it is stable. Now if it is 2 degree amine, so if it is 2 degree amine, so 2 degree amine will have one hydrogen and is reacting with, let's say, nitrous acid, NaNO2 and then HCl, okay. So it will produce N double bond O, okay. Okay, so this one is called nitrosoamine compound, nitrosoamine compound, okay. And how to identify this? There will be one yellow green oily layer, means whenever yellow green oily layer is formed, right, then it is 2 degree amine. Is that clear or not? Okay. Sometimes this reaction is also called Lieberman's nitrosoamine test, okay. So how to identify this? Whenever like one clear liquid will be given and you don't know that it's 2 degree amine, okay, the moment you react it with NaNO2 HCl, it will produce one yellow green oily layer, okay. Then and there you will say that it's a nitrosoamine compound, okay. Let's do some question. Suppose I'm giving CH3 CH twice NH, okay, and let's say it's reacting with HNO2. In its place you can write NaNO2 HCl also. So what you have to do, remove one hydrogen, and in that hydrogen place you have to write this nitroso compound, means this whole part, and double bond this part. So this is nitroso part. Okay, right? Let's do one more question so that it becomes very clear to you. Suppose I'm giving CH3, NH and CH3, right? And it's reacting with HNO2. So you just have to remove this hydrogen, and then you can draw it here also. So this is also nitrosamine compound. Okay, clear? Now if we do 3 degree, if it is 3 degree amine, so 3 degree amine is, let's say, R3N, and it's reacting with HNO2. Okay, now what will happen, HNO2, if it breaks, it will give you H plus and NO2 minus. Okay, so remember the here you have to memorize it. Okay, so R3N, it will make bond with this hydrogen plus, and then NO2 minus. Okay, now this one is called trialkyl. You have to memorize this. Okay, trialkyl ammonium nitrite compound, nitrite compound. Okay, so it's a crystal. Okay, whenever you get crystal, so it will be this one. All right, I hope you understood this, right? So let's do some example for that one. Suppose I'm giving CH3 and CH2 CH3 and then CH3. Okay, and let's say it's reacting with HNO2. So hydrogen will make bond with this nitrogen. Okay, and then nitrogen will acquire on positive charge, and outside the third bracket you will get NO2 minus. Let's do one more question so that this becomes clear to you. Let's say that I'm giving identical alkyl here. Okay, and let's say NaNO2 and HCl is given. Although NaNO2 HCl is given, I know that it's HNO2, right? So in the reactant side, nitrogen does not have any hydrogen, so you just add this hydrogen, give a positive sign, give a third bracket, and outside you write NO2 minus. So I have shown you the different variations by which you can give the final answer. Okay, now if I sum up this whole chemical reaction, so if it's aliphatic 1 degree amine, so it gives you alcohol as final product. If it's aromatic 1 degree amine, it gives you benzene diazonium salt, right? If it's 2 degree amine, it can be aromatic also, it can be aliphatic also. It gives you nitroso compound, nitroso amine compound, which are what? Which are yellow green in color, right? And then if it is 3 degree amine, it gives you trialkyl ammonium nitrite crystals. Although the formation of crystal, it might take some time, but if you keep it undisturbed for some time, then it gives you the crystals. Okay, so I hope it's clear for nitrous acid test. Okay, now let's move on to the next one. This will help you in distinguishing. Okay, there are lots of distinction question where they will say that how to identify 1 degree amine, 2 degree amine, or aromatic amine and aliphatic amine. You just have to write the name. Okay, so that's why I have not explained the structures in detail, only the final product and what test it is I have explained it properly. Now the next one is Hinsberg reagent. Okay, this is the last distinction reaction. Hinsberg Hinsberg, I think spelling is wrong. Wait. Hinsberg test, okay. Okay. So in Hinsberg test, the reagent that we use here is benzene sulfonyl chloride, okay. The reagent that we use is benzene sulfonyl chloride, and it's also called Hinsberg reagent. Okay, now what is the structure of this one? The structure of this compound is S11O and then Cl, okay. We can also write it as C6H5SO2Cl, correct? Or we can also write it as benzene ring SO2Cl. Now this Heisenberg reagent, it reacts differently with 1 degree, 2 degree and 3 degree amine, okay, clear? So now let's do this. So if it's 1 degree amine, here no aliphatic and aromatic amine, okay, it's just simply 1 degree amine. Let's say RNH2 is given and it's reacting with this one. Now what actually you have to do here, from here you have to remove what? One hydrogen. You have to remove one hydrogen from nitrogen, okay, and from here you have to remove Cl and make bond. So it's R and H, reverse the structure. So if you reverse the structure, I think it will be something like that, because I have to make sure that sulfur makes bond with it, okay. Now when it is 1 degree amine, you can see clearly that this nitrogen has one hydrogen, yes or no? So here one hydrogen is present, so that's why this whole compound will be acidic in nature and it will be soluble in alkali or any base. It will be soluble in alkali or base. Is that clear? Now let's do other one. If it's 2 degree amine, then what will be the case? If it's 2 degree amine, obviously that along with nitrogen you have what? How many hydrogen? One hydrogen, right? And then this benzene sulfonyl chloride is there. You can draw it like this also. Then again from nitrogen you are removing one hydrogen, and then this sulfonyl chloride part will make bond, okay. Now if you look carefully here, with nitrogen there is no hydrogen, yes or no? No hydrogen present. So that's why this compound, this product is not acidic, and since it's not acidic, it will not be soluble or it will not react with alkali, okay. So it's not soluble in alkali. Okay. Now what about 3rd degree amine? So if it's 3 degree amine, you know that in 3 degree amine there is no hydrogen, right? So it will never react with, it will not give any product. So here, since no hydrogen, no product. And you have to specify, like sometimes they ask question, the reason is here no hydrogen present with nitrogen atom, that's why, okay, that's why you don't get any product. Now if I analyze everything properly, then I can say that if it's 1 degree amine, right, just 1 degree amine, it gives you one product that is soluble in alkali, right? because it has one hydrogen with nitrogen atom in product, right? So if it is 2 degree amine, then it produces product but not soluble in alkali. The reason is no hydrogen with nitrogen atom in product. And if it is 3 degree amine, then here you get no product. So I have already explained you this I have already explained you this part. I hope it's clear, right? Now let's do some question, like if they ask numerical question, then how we will do it. Okay, so let's do some question regarding related to this Hinsberg reagent. So suppose the first question is CH3 CH2 CaNH2, right? And this is this sulfonyl chloride is given, right? So what will happen? From here you remove one hydrogen, and you know that is 1 degree amine, right? And from here you remove the Cl, so your answer will be CH3 CH2 NH, then S double bond O. You can draw it as SO2 also, it's okay, but I prefer to write it in expanded form in the product, so I have written it like that. Means what I'm trying to say there, the same compound you can write like this also. This is also correct, but I prefer to write it in expanded form. So let's do another question. Suppose I'm giving this one, and let's say it's reacting with this SO2 Cl, right? So what will happen? I'll twist the structure a little bit. Let's say I'm writing this NH here, so instead of writing this CH3 directly, I will write it below, okay? And I will remove this one hydrogen, and then S double bond O. I'm doing it as per my own convenience. There is no such rule that you cannot remove it or you can remove it like that. You can do that, okay? Means the same structure you can draw it in this way also, that is also correct, but this one I did it as per my own convenience. So suppose I'm giving this is also correct, okay? This is also correct. You will get full mark for that, okay? Both the structures are correct. It's just that which one you feel convenient, you do it. Alright, I hope it's clear. So it is, we are done with the chemical reaction part. Now another type of chemical reaction is there, that is called electrophilic chemical reaction. Okay, so we'll do that. Electrophilic chemical reaction of amines. So under electrophilic chemical reaction of amines, you know that this NH2, let me write this NH2, okay? This one is strong ERG group and produces ortho and para product. They will ask reason for that. You will say that because ERG shows plus I effect and increases electron density at ortho and para position. Okay, so basically whenever NH2 is there, okay, let's say NH2 is given here and one electrophile is added. Electrophile you already know, anything that is positive charge. Other varieties are also there, but for board level that will be more than null, so it will be ortho product, and it will be, this electrophile will be at para product. But the problem is NH2 is a very strong EWG group, not EWG, ERG group, and because of that extra strong ERG effect, it gives you like meta product also sometimes, although it should be giving ortho and para product, but sometimes it gives meta product also. Sometimes in one benzene ring, here you can see only one substitution is there, right? Only one substitution is there. It might give you 3 substitutions also. So that's why we have to control its highly activating power. Okay, so we'll discuss that. NH2 is very strong ERG and have strong activating effect. Okay, and have very strong activating effect, so its activating power has to be controlled by acetic anhydride. Alright, so here I'll be showing you this controlling part. Okay, so it's very important, very important. So I'll just mark it as no point. Let's explain this. So suppose NH2 is there, okay, and it's reacting with acid anhydride, CH3CO2ISO. You already know what will happen. Like if you recall, let me explain this separately. I've told you that if RNH2 is there and if it reacts with to differentiate, I'm writing RCO, R1, so CO2 so what product you will get from here, what part you will get? I think this one. So one of the hydrogen will be removed, and in its place you will get this one, right? Yes or no? We did this before also. Yes, so same thing we'll do here. So if you apply the same concept, I can say NH will be there, then C double bond will be there, and then CH3 will be there, right? And this is the one. So this one is aniline, yes or no? And this one is acid analyte. Remember the name, okay? This is very important. Okay, acid analyte, and it's also, its name is also N-phenyl ethane amide. Okay, now from here to here it's controlling. This one is controlling the activating power, controlling step. Now after the reaction is done, you can again change this one, this acid analyte to aniline, by doing acidification, H3O plus. Okay, so it will again change to NH2, so it's again reactivating. So from here to here is again reactivating. Is that clear? So first step is controlling step, then we will do the electrophilic reaction, and then once the electrophilic reaction is done, then again we will reactivate it by removing this CONH2. I hope you understood this. Okay, so let's do one question. So before that, let's write the reagent part. You already know if it's bromination, right? So what will be the reagent? Br2, yes or no? Clear? And then here you will use CH3 COOH. This one will behave as catalyst. Okay, and the electrophile that you will get from here is Br plus. Okay, now under this bromination we have to do two parts. First part, okay, let's say NH2 is directly reacting with bromine, this one. Okay, okay, in aqueous form, means NH2 without controlling is reacting with Br2 and aqueous, and you already know what is Br2 and aqueous, right? What is Br2 and aqueous? It's called bromine water, right? So in simple terms, if aniline reacts with bromine water, which can also be written as Br2 plus H2O, so you will get bromine at 3 positions. That's mainly because NH2 is very activating, right? Yes or no? And since you did not control its power, so you are getting this one. But now let's say that I'm using the same thing but after controlling it. So what will be the case here? So under bromination, forget about this bromine water and stuff. Just remember that first step, we are doing the reaction of aniline with bromine without controlling it. Okay, so we'll get this one, these 3 products. Bromine will be substituted at 3 position. But now if I say that I'll do the reaction but after controlling it, so let's say NH2 and is reacting with Br2, okay, not water but in the presence of CH3COOH. So immediately it will not react, okay, it will again give you the 3 product. So what to do? So first I will control its power, okay, so I will control its power by CH3CO to iso, so it will change to acetanilide, that is C double bond O CH3, right? Then I will treat it with Br2 in the presence of CH3COOH, okay. Then what will happen? You will get ortho and para product. So this is your first one, Br, and then this is your para product. So this is major product, but now I don't need this C double bond H2 part. So this is your major product, you know that, because para product is always major product. So what you will do, this is your ortho product because it is situated at ortho position, and this one is your para product. Now you will do acidification. The moment you do acidification, both the ortho and para product, that CO part, it will change to NH2. Okay, so that's your final answer. This is your para product, okay, and this is your major product. Okay, I hope you understood this, right? So what we are doing here, I cannot react this aniline directly with bromine, it will give you 3 products like this one, right? So what I did, to get bromine in one position, that is in ortho and para position, I first reduce the activating power of NH2, yes or no, and then once that ortho and para product is formed, I removed that part, COCH3 part, yes or no, and then I got this NH2 back, okay. So first step is controlling, then I did that electrophilic reaction part, and then I reactivated the compound, okay. Next chemical reaction is the second one, nitration. So if it is nitration, what is the reagent here? The reagent will be concentrated HNO3 and concentrated H2SO4, okay. And the electrophile that you will get from here is NO2, right? I have already explained you this one, and nitrogen will be the bonding side, right? Then in previous chapters I have explained this. So what will happen? Let's say NH2 is reacting with this reagent, okay, but the first step similar. This time I will not control it, okay, I'll just let it react with this one. If concentrated is not written also, it's okay. So what it will do is it will give you meta product also this time. So ortho product, then this is para product, right? And then here it will give you meta product also, but we don't need meta product. and the amount of meta product is huge. Okay, here. Okay, so now what to do so that the major portion is ortho and para product. Now if I give you just percentage wise, so let's say this is 51%. Okay, this one is 49%, and 2 to 3% is from, not 49%, sorry, like I'm just giving you a rough idea. Let's say this one is 48% or something like this, and this one is just 1 to 2% like that. But we need ortho product in major amount, right? So what to do? So here what I will just do the controlling thing again. Okay, so let's say that we are doing the same reaction but under control condition. Aniline is there, is reacting with acid anhydride. This is acetic anhydride is the actual name, but acid anhydride is general name of this whole class. Okay, like we say alcohol and ethanol. So here acetic anhydride is that ethanol, and alcohol is acid anhydride. So this is the one. So controlling part done. Then I will let it react with HNO3 and H2SO4, and here I will get now ortho and para product, and here the amount of ortho product is like good amount. Okay, as compared to the previous case. Okay, and then I will do acidification. The moment I did acidification, then what will happen? I am again reactivating the structure, so that C double bond O CH3 part, this whole part, it will be removed. Okay, so it will change to CH2, and you are getting the answer, this one and this one. So this is your major product. Okay, your para product is always your major product. Clear? The last one is sulfonation. So in sulfonation, we don't do this activating and reactivating. This process is completely different. So in other reactions you are memorizing like half an understanding, but this one better you memorize like full, this sulfonation. So NH2 is given, let's say is reacting with sulfuric acid. Here the reagent is, you memorize it. Okay, reagent is H2SO4 or concentrated H2SO4. So let's say it's reacting with H2SO4. Okay, okay, so if it reacts with H2SO4, so what you will get? You will get H plus this one. Just memorize this, and here you are getting HSO4 minus. Then you are heating it, then you will get here NH3 plus, then here you will get SO3 minus. So this one is actually Zuiterion. They ask question on that. Okay, and then it will undergo some rearrangement. Okay, so you have to get double-headed arrow. Then this one will change to this SO3H. Okay, clear? And you have to memorize this. Okay, name. They have asked one question based on this name. So sulfonalic. Here I don't think it's possible to write the full name. Sulfonalic acid. Okay, sulfonalic acid. Is it clear? Now with this we are done with this electrophilic reaction. Okay, now here two homework question for you. One homework question is why aniline, it's in your all-in-one book, you can directly copy paste it. Okay, does not undergo Friedel-Crafts reaction. ठीक है. Next thing is, next question. You have done this, right? This is aniline. So aniline is there. Okay, let me explain. This is important. Okay, so NH and then this one CO, NH2 is CO, CH3 is there. So this is acid analyte. Now this one is more basic. Okay, this is more activating, and this one is less basic comparative to aniline and less activating. Simple term, this NH3. Okay, here NH3 is very strong ERG. And this NHC double bond CH3 is comparatively weak ERG. Now they will ask the reason why. Okay, what's the reason behind that? The reason is, pay attention here, there is lone pair of nitrogen. Okay, this lone pair, it usually go if there is no C double bond O part. Okay, this lone pair, it starts doing resonance with the benzene ring. Okay, means it goes to the benzene ring. But now since this part is there, so instead of going here, it goes there. So that's how the activating power is reduced. Okay, like they can ask this question in different way: why it is less activating, why it is more activating, how like activating power of aniline can be reduced or something. All you have to do, like the lone pair on nitrogen atom, after reacting with acid anhydride is acidic anhydride. So what is that acidic anhydride here? You know what is acidic anhydride, right? CH3 CO 2iso is in resonance with carbonyl, that is C double bond O group. Okay, so one important thing here, resonance means they can also use the word conjugation. So resonance is conjugation. So this statement that I have given, they ask question on this point, like 1 mark question. Okay, so whenever they ask any question related to aniline and acid analyte, you just write this statement. Okay, that once it reacts with acidic anhydride, the lone pair of nitrogen atom what is involved in conjugation or resonance with carbonyl group. Okay, right? So with this we're done with the chemical reaction part. One small topic is left, that is called basicity or order of basic strength of aniline, that we will do in our next class. Actually in our next class we'll be doing numericals mainly, and then the other part. Okay, so thank you class.